Hello students, welcome back to this channel. Yesterday I gave you a worksheet of chapter number 3, motion in a straight line. It includes few questions. So today I will solve few of that question. You will also find out a PDF of that in the description section. Okay, so let's start with question number 1. Okay. You can see here that a plane is traveling 400-meter north, then 300-meter south, and then 1200-meter upward. You have to find out the resultant displacement. Okay, students, so don't get confused with north, south, and up, down. Okay, north and south, this will be in a horizontal plane. You cannot say north in this direction. Okay, north, south, east, west, that is in the horizontal plane of Earth. Okay, so if I draw a horizontal plane, okay, let's take north, north, south, west, east. Okay, so see here, a plane is traveling 400-meter north. Let's say this is the starting point. Okay, this is the starting point. In horizontal plane, this distance is 400-meter. Okay, then it is traveling 300-meter south. So from here, coming back in this way. So this distance 300-meter. Clear? And then it is moving 1200-meter up, means upward this way. Okay, and this distance is 1200-meter. This remaining distance 400 minus 300, this will be equal to 100, and this is 1200-meter. Now you have to find out the displacement. What is displacement? The shortest distance between initial and final position. So this is the displacement. Okay, now this is a right angle triangle. Okay, it's in this way. See, this is the 100-meter distance and this 1200-meter distance. Let me write down this 100-meter distance and this 1200-meter distance. Okay, 100, 1200, it's in this way. Okay, so it's a 90-degree angle. So this is right angle triangle. Okay, 100-meter, 1200. If I draw it clearly, it's like this: 1200, 100. So using Pythagoras, you have to find out this displacement AB. So that will be equal to under root of 1200 square plus 100 square. Okay, so 1200 square, that is 14400 plus 100 square 10000. So this will be equal to 1451234. Now let me take the square root of 145,000. So let me take out the calculator. So 145,000 and its square root, it's 1204.15. 1204.15 meter. Okay, so this is the answer of first question. Clear? So the closest option is 1200 meter. So the answer will be option A. Next, question number two. In question number two, it is given that the object varies its displacement according to equation. This equation y equal to 3 by 8 t square minus 3t plus 5. And you have to find out the instantaneous velocity at t equal to 4. Okay, so remember, when there is average velocity, its formula will be v final velocity minus initial velocity v2 minus v1 upon time. But when there is instantaneous velocity, the formula is v equal to either dx by dt or dy by dt. Okay, so let's take the derivative. 3 by 8 t square minus 3t plus 5. Okay, so derivative of 3 by 8 t square. So 3 by 8 into 2, t raised to 2 minus 1, 1, minus derivative of 3t, 3, derivative of 5, 0. Okay, so the velocity equation for velocity will be equal to 3 by 4 t minus 3. Clear? So the instantaneous velocity at t equal to 4, v will be equal to, just put on the value here. Sorry, it's my mistake. It's minus 3, not 3d. So 3 by 4 into 4 minus 3. So 4 4 gets cancelled. It's 3 minus 3. Velocity is 0. That means the body is at rest at t equal to 4 seconds. Okay? So note down question number 2. Now let's move to question number 4. Question number 4 says that a car is moving at a speed of 120 kilometer in 2 hours in a straight line. So let's take a straight line. Okay. What is the distance? 120 kilometer. In what time? 2 hours. Okay. This is elastic distance d1 time t1. Then it moves to the left for 50 kilometers in 1 hour. So this distance d2 is equal to 50 kilometer and time t2 is equal to 1 hour. Now we have to find out the average speed and velocity. Okay, so first let's find out about speed. Okay, what is the formula of speed? Total distance upon total time. So what is the total distance? d1 plus d2. Okay, this is total distance, and that is equal to 120 plus 50, that is equal to 170. Total time t is equal to t1 plus t2. So 2 hour plus 1 hour, this is equal to 3 hour. So speed will be equal to total distance 170 upon total time 3. So 170 divided by 3. Okay, 3 6 are 8. Sorry, 3 5 are 15. 206. 56.66, taking round figure, 56.67 kilometer per hour. This is the average speed. Okay. Now let's find out the velocity. Okay, what is the formula for velocity? Displacement upon time. So now what is displacement? The shortest distance between the initial position and final position. So this is the displacement, and this is equal to, we can use Pythagoras, 120, 50, so this will be equal to 130 kilometer. So formula for velocity, what is the total displacement here? 130 kilometer. Okay, what is the total time? 2 hours plus 1 hour, that is 3 hours. So velocity will be equal to displacement upon time. So V will be equal to 130 by 3. Okay, 3 4s are 12. Okay, 10, 3s are 43, 43.33. So this is the velocity and this is the speed. Okay, so just note this down. Okay, now let's move to question number 5. Okay, now question number 5 says that an object moves from point O to P in 18 seconds. Okay, so from point O to P, time equal to 18 seconds and distance is equal to 0 to 360. So 360 minus 0, 360 meter. Okay, and from P to Q, it takes 6 seconds. So at this time, the distance will be from 360 to 240. The distance covered is 360 to 240. So 360 minus 240, that will be equal to 120 meter. Okay, now you have to find out, there are two questions. Okay, the average speed and velocity from O to P and the average speed and velocity from O to P and P to Q. Okay, so now let's solve the first one. A, from O to P. Okay, now from O to P, for velocity, displacement equal to 360. Distance, again 360 because it is a straight line. Okay, and what is time? 18 seconds. So velocity V is equal to total displacement 360 upon time 18. So 360 upon 80, that is equal to 20 meter per second. Okay, this is velocity. And for the speed, this is 360. Okay, speed, distance upon time. Again, what is the distance? 360 upon, what is the time? 18. So this is also equal to 20 meter per second. So in the first case, from O to P, velocity and speed both are same. Okay, now let's move to the next one, that is B, and that is from O to P and back P to Q. So now first, what is displacement? Okay, what is this meaning of displacement? So what is distance between initial and final position? What is initial position? O. And what is final position? Q. So what is this distance? What is this displacement? 0 to 240. So this will be equal to 240 meter. And distance is the total path length. So from 0 to 360 plus 120. So this will be equal to 360 plus 120. This is equal to 480 meter. And what is the total time? From O to P 18 and P to Q 6. So 18 plus 6, this is equal to 24 seconds. So now velocity, displacement by time. So 240 upon time 24, that is equal to 10 meter per second. Okay? And speed, see, I have taken symbol S for speed here, but in general case we are taking symbol S for displacement. So let me write it down. Speed. Speed will be equal to distance. Wow, what is the distance? 480 upon time 24. So this will be 20 meter per second. So speed in both the cases is 20 meter per second, but velocity in the first case it's 20 meter per second, and second case it's 10 meter per second. Okay, so just note down question number 5. This question number 5 is example number 3.1 of chapter 3 in NCERT textbook. Now let's move to the question number 6. Okay, in question number 6 is given that an object is moving at a display according to the equation x equal to a plus bt square, where a is equal to 8.5 and b equal to 2.5. Okay, and the time t1 equal to 2, t2 equal to 4. Now you have to find out the velocity at t1 and at t2 and the average velocity between t1 and t2. These are the given thing, and next you have to find it out. Okay, so first we'll find out v at t1 and t2. So this means that it is instantaneous velocity. If you have to find out the velocity at any specific instant, that means that is instantaneous velocity. So the equation for velocity, let me first write down the equation for the displacement. Putting the value of a 8.5 plus putting the value of b 2.5 t square. For instantaneous velocity, v is equal to dx by dt. That means d by dt of 8.5 plus 2.5 t square. So this will be equal to derivative of 8.5, 0, 2.5 into t, 2, 5, 2 minus 1, 1. So velocity, equation for velocity is equal to 5t. So now at t1 equal to 2, v1 will be equal to 5 into 2, that is equal to 10. And at t2 equal to 4, v2 will be equal to 5 into 4, that is equal to 20 meter per second. Okay, so just note down this, then we will solve the next one. Now let's see the next one. Now we have to find out the average velocity. Formula for average velocity: total displacement upon total time. Right, means x2 minus x1 upon t2 minus t1. So now equation of x is given. At t1 equal to 2, x1 will be equal to 8.5, 2.5 into 2 square, 4. So 8.5 plus 2.5 into 4, that is 10. This is equal to 18.5. This is x1. And at t2 equal to 4, x2 will be equal to 8.5 plus 2.5 into 4 square, that is 16. Okay, 4 square is 16. So 16 into 2.5, that will be 40. Okay, 40 plus 8.5, 48.5. Okay, so now average velocity V will be equal to x2 minus x1 upon t2 minus t1. So what is x2? 48.5 minus 18.5 upon T2 is 4 minus 2. 48.5 minus 18.5, that is equal to 30 divided by 2. This is equal to 15 meter per second. Okay, so this was about average velocity. So remember, when you're finding out instantaneous velocity, you have to take derivative, differentiation of the equation of displacement x. And when there is average velocity, then find out the initial position, final position, okay, initial time, final time, and then take this formula. Okay, so note down the second part of question number 6. So that was about question number 6. The question number 7 that I gave you in yesterday's worksheet is similar to question number 6. So you solve it accordingly. Okay. So students, that's it for today. Thank you.